So I'm looking at the security AI surveillance camera today, once again. So those are the contents of my presentation. My introduction: security in my society is at a very low rate, as we know that. The use of a surveillance camera is to record each and every person that comes across that camera. But the surveillance camera is very expensive and not easy to afford by the low standard people or the moderate people, low income earners. It is really an expensive equipment to have, though it helps in fighting crime. So my major concern here is to use what is it called? Using software, helping people know how to get this software, how to build the software instead of buying the surveillance camera. To start using the software instead, which is much cheaper. So I'm going to be using an open data set from OpenCV. Here, you just install OpenCV, pip3, those who are using Python 3, those who are using Python 2, pip3 install, OpenCV, Python. There you'll be able to save your what? To install OpenCV. Then you just import it. Import CV2. Then the type of data factors that I considered before choosing my AI dataset. My AI is visual. It's going to be using visual data, so it requires images. Its role as an AI is to store the records on the faces and bodies of people. So I need such data to train it. It has a wide range of human facial images that are able to train the AI model. Remember, this AI model, it's going to learn how to, you're going to see in the features. It's my next slide. Then it's easy to use and cheap since it is an open source code. There's a lot of time saved. The important features an AI will use from the data set. Those are the features. It has to learn the distance between your eyes so that you know that this is human, the depth of your eye sockets, the distance from the forehead to the chin. So all this help it to detect, to know that this is a human being. Then Bayesian theorem, that's how it states. So further explanation, the likelihood of the probability of A being true over the probability of B being true. That is the likelihood that A and B are true. So also here, the probability of B being true and A being true shows us that also A multiplied by A being true out of B being true. That is the Bayesian theorem. Then the naive Bayes, it's part of Bayesian theorem, but this one is a machine learning model that is used for large volumes of data. It can be used. Okay, people can work with naive. It gives them access to work on large volumes of data. So it is a recommended way of what approach. So Bayesian network is the one for it. It deals with probabilistic graphical model. It's a probabilistic graphical model where it allows you to predict. Yeah, it allows further predictions, anomaly detections, diagnostics, automated insights. Those are other, but further explanation on it, flexible and interpretable representation of a gene probability distribution. It is a useful tool in knowledge discovery as directed. As we say that it is a graphical model. So difference between Bayes' theorem and naive. The difference between naive Bayes and Bayes' theorem is that naive Bayes assumes conditional independence, whereas Bayes' theorem does not. This means the relationship between all input features are independent. Naive, by the way, it is not a great assumption. That's why you call it naive. Naive. Well, that's why we call it naive. So difference between naive Bayes and Bayesian networks, the difference is that naive Bayes assumes conditional independence, whereas Bayes network means the relationship between all inputs. All input features are independent. So there is an independent network. Thank you for listening.